All right. Good afternoon, everybody. So I think we're recording now, especially kay Ana, na feeling ko buong SEM, siya yung consistent na first honor sa pagpasok. Pinakamaaga laging pumapasok. Nauna pa yan sa akin. And then, of course, our mainstays, Jonathan and Noriel. So today we'll finish, hopefully, the fifth lecture note for the course. And there are only two things left to discuss in 155. Una, yung mga properties ng Riemann Integral na most of them ay kilala nyo na. Ginagamit nyo to simula nung 36, 37, and 38. So ngayon titingnan lang natin or sisilipin natin ano yung mga proofs. Ano yung mga proofs nila o ano yung mga driving forces kung bakit sila ay totoo. And then we will culminate the course by stating and presenting a quick proof of the Fundamental Theorem of Calculus na isa na namang napakagamit na theorem, lalo na yung second statement niya na ginagamit natin pagko-compute ng definite integrals, which basically coincides with our concept of the Riemann integral. Tapos yung first statement niya, fundamental siya kasi siya yung parang nagtatali sa konsepto ng derivatives and integrals together. And that's why I think that's one of the reasons why I think it is called the Fundamental Theorem of Calculus, because it basically weaves together the two branches of calculus, yung derivatives at saka integrals. So more on that later, but we will first look at some results that will prove to be useful when we are trying to write the proofs for the Fundamental Theorem of Calculus. And again, incidentally, ang karamihan ng mga ito ay kilala na natin sa elementary calculus. Take for instance, Theorem 5.7. So Theorem 5.7, sinasabi niya lang na kapag sure ka na meron kang isang function na differential na integrable, actually hindi pala integrable, so umpisa siya ay bounded. Okay? So meron kang bounded function, tapos yung function na yon ay magiging integrable sa closed interval AB if and only if ito ay integrable sa pair, okay, ng closed intervals na nag-union papunta kay AB. So basically, ang sinasabi niya, integrable si F kapag si F ay integrable sa dalawang integrals, sa dalawang intervals AC and CB, where C is an intermediate point of the closed interval AB. So basically, ang idea, meron kang AB, okay? Tapos meron kang interior point na C. Si F ay integrable if and only if siya ay integrable dun sa dalawang mas maliit na subintervals, okay? The proof of this will basically revolve around yung konsepto ng upper at saka lower sums doon sa dalawang subintervals na mabubuo. Because basically, kung meron kang interval AB, tapos kumuha tayo ng isang partition inducer niya. Alright, so x1, x2, x3, xk, tapos hanggang kay x sub n minus 1. Okay? Tapos papunta kay x sub n. Pag hinati natin to sa dalawang subintervals, so halimbawa yung partition inducer na P, siya si x0 hanggang kay xn. Hinati ko siya sa dalawang sets. Halimbawa, yung unang set P1 ay si x0 hanggang kay xk. Tapos yung P2, siya ay si k plus 1 hanggang kay xn. Alright? So pag kinuha ko yung upper minus lower Riemann sum relative to P, so kunin ko yung P of Fp minus the lower sum of F relative to P, equal lamang to doon sa difference yung upper at saka lower sums doon sa dalawang partitions or dalawang sub-partition intervals. Partition inducers. So basically, ang mangyayari lang, siya ay magiging sum nitong dalawa na to. P1 plus UFP2 minus LFP2. Right? So ito yung basically gagamitin kong idea dun sa mga susunod nating proofs na dahil ito, yung U minus L of F relative to P ay isa lamang summation. Ano? Tapos hinati ko lang yung partition inducer sa dalawang grupo. Mula kay x0 hanggang kay xk, tapos mula kay x sub k, actually dapat pala to ay mula kay x sub k din. Mula kay x sub k papunta kay x sub n. Alright? So, etong upper sum na to dun sa buong P, or yung upper minus lower sum dun sa buong P, ay equals sa upper minus lower sum kay P1 plus yung upper sum minus lower sum naman with respect kay P2. And actually, the rigorous proof about this, or the rigorous proof of this, will be or can be written by simply writing this down as a summation. Sulat nyo to as a summation, tapos sulat nyo to as a summation, sulat nyo to as a summation. So makikita nyo na mag-a-add up talaga yung dalawang differences papunta dun sa difference with relative to the big partition P, or the big partition inducer P. All right? So, hindi ko na siya i-prove, pero ito yung rigorous, ito yung kanyang, ito yung argument why this will make sense. And I think it's easy for you to write a proof for this. Tingnan nyo lang to sa summation, tapos paghiwalayin nyo lang yung mga terms na nanggagaling kay P1, tapos yung mga terms na nanggagaling din kay P2. Okay? So, yun yung idea na nagagamitin ko dun sa proofs ng mga properties. So, dun sa proofs ng ilang mga properties rito. Okay? Now, Theorem 5.7 is an if and only if statement, so we need to do the proof in two folds, all right? The first one, assume ko muna na si f ay integrable sa closed interval AB, tapos ipapakita ko ito ay, actually, papakita ko si f ay doon sa closed interval AC at saka sa closed interval CB. And the main ingredient for the proof is the integrability criterion theorem 5.1 plus yung argument na shinare ko sa inyo kanina. Okay? So let's look at the proof. So f is integrable on the closed interval AB. That would be our assumption. Dahil si f ay integrable sa closed interval AB, by theorem 5.1, pag binigyan tayo ng kahit na anong epsilon greater than 0, we can find a partition inducer P of the closed interval AB such that this inequality is true. Again, that's just the integrability criterion. Ano? Tapos, hahatiin ko ngayon si partition inducer P sa dalawang parts. But first, let me assume, or let me tackle the issue na kung si C ba dapat na kay P or hindi. Right? So kung si P ay kung si C ay wala kay P, I mean kung si yung subdivision point natin dito ay wala dun sa partition inducer C, pwede ko sa partition inducer P, pwede ko siyang idagdag. Bakit pwede ko siyang idagdag? Kasi yung P union the set containing C is a refinement of P, right? Tapos ano nga ba nangyayari kapag meron tayong refinement? So pag dinagdag ko si P, si C kay P, all right? Liliit yung upper sum, right? So pag nagre-refine tayo ng partition inducer, lumiliit yung upper sum, pero lumalaki yung lower sum. So basically, if I consider the refinement P star equal to P union the set containing C, then I'll get a lower upper sum and a larger lower sum. Tapos, syempre, yung refined difference will be smaller than this guy, right? Kasi mas maliit yung minuend, mas malaki yung subtrahend. So yung U of FP star minus L of FP star ay mas maliit dito. Pero ito ay mas maliit sa epsilon, so this guy will also be less than epsilon. So whether or not C is in P, then totoo pa rin itong epsilon inequality nito. So it is safe to assume that that C is an element of P. So si C ay isang isa dun sa mga partition points, dun sa partition inducer P. All right? Kailangan kong masama sa picture si C kasi di ba gusto ko mapakita integrable si F dun sa closed interval AC at saka sa closed interval CB. So dapat si C magiging parte ng partition inducer para dito at saka partition inducer para dito. So now I will assume that indeed P is part of that C is part of the partition inducer P. Tapos hatiin ko ngayon yung partition inducer P nakasama na ngayon si C sa dalawang sub-partition inducers. Kukunin ko si P1, which is just the elements of the partition inducer P that is strictly between A and C, right? Kaya importante na kasama dapat si C. Kasi para si P1, maging partition inducer ng closed interval AC. Tapos si P2 naman, siya yung intersection ng P at saka ng closed interval CB. Now, since C and B are both in P, then this intersection, si P2, ay partition inducer ni C, B. Alright? Now, tapos gagamitin ko ngayon yung argument natin kanina na yung upper Riemann sum relative to P minus lower Riemann sum relative to P ay equal sa dito plus D. Alright? Ito yung kinento ko sa inyo kanina na isang ingredient dun sa proof na hindi ko na pinrove rigorously, right? Property lang naman siya ng upper minus lower being a summation, right? So the rectangle guy is equal to the sum of the oval guy, all right? So pareha silang equal. Tapos anong alam ko dun sa mga naka-oval, ito ay greater than or equal to 0, ito ay greater than or equal to 0. Kasi alam natin ang upper Riemann sum ay laging mas malaki sa lower Riemann sum. Okay? So both of the oval guys are positive. Tapos pag in-add up ko sila, ang makukuha kong sum ay mas maliit sa epsilon. And epsilon is also greater than 0. So that means both of the oval guys ay parehas dapat mas maliit kay epsilon. Kasi silang dalawa ay positive na pag in-add ko, mas maliit pa kay epsilon. E di lalo nang mas maliit kesa kay epsilon, silang dalawa on their own. Alright? So that means ito ay totoo, tas ito ay totoo. But what is P1? P1 is a partition inducer of the closed interval AC. So if you are given an arbitrary epsilon greater than 0, we have found a partition inducer P1 of the closed interval AC such that this inequality is true. So integrability criterion 5.1 will kick in. That means we can say that f is integrable on the closed interval AC. And the same argument goes for concluding that the function f is Riemann integrable on the closed interval C, B, therefore completing the forward proof. Okay? So ang laking gamit ng nung integrability criterion 5.1. When I was reading the text for the first time last semester, I was wondering, bakit pinangalan ng integrability criterion yung theorem 5.1? Kasi ang dami naman nating integrability criterion, so marami pa nga rin sa kanila if and only if then. Bakit of all of them, piniling pangalanan nung textbook na integrability criterion si theorem 5.1? And apparently, ginawa yon kasi paulit-ulit ginagamit yung theorem 5.1 dun sa mga proofs ng ibang mga may pangalang theorems, or mga major theorems for integrability. All right? So is the forward proof clear? Because if you don't have any questions, I'll proceed to the converse. Prove natin converse. Para naman sa converse, i-assume natin si f ay integrable doon sa dalawang mas maliit na closed intervals. Tapos gusto kong ipakita ngayon si f ay integrable doon sa union ng dalawang closed intervals na yan. Or in other words, f is integrable on the closed interval AB. Okay? Tapos ito, integrability criteria na naman, or integrability criteria na naman yung gagamitin ko. So dahil alam natin si f ay integrable sa dalawang closed intervals na yan, makakahanap ako ng dalawang partition inducers. P1 of AC and P2 of CB, such that for any given epsilon greater than 0, upper minus lower sum relative to P1 will be less than epsilon over 2, and upper minus lower sum relative to P2 will be less than epsilon over 2. Kasi alam nyo na kung anong gagawin ko. Kasi ito plus ito ay equal sa upper minus lower sum ni F relative kay P, where P is P1 union P2, which is a partition inducer of the closed interval AB, right? And then that upper minus lower sum relative to P will be less than epsilon plus epsilon over 2, epsilon over 2 plus epsilon over 2. That will sum up to epsilon. So therefore, ito yung makukuha ko. So, ibig sabihin, sa kahit anong epsilon greater than 0, nakahanap tayo ng partition inducer P, namely, the union of P1 and P2 such that this inequality is true. So therefore, by the converse of Theorem 5.1, ibig sabihin ay integrable si F dun sa buong closed interval AB. Alright? So yun yung proof ng yung unang statement. But Theorem 5.8, tama ba, or 5.7 has another pahabol. May PS siya. May pa-PS siya na result. Ang sabi niya, if F is integrable on the closed interval AB and C is an intermediate point of the closed interval AB, then pwede nating evaluate yung integral this way. The integral from A to B is equal to the integral from A to C plus the integral from C to B. Okay? Now, medyo ano nga lang to, medyo this is a specific case of the theorem that you might have used in elementary calculus. Kasi anong problema rito? Ang assumption kasi natin dito, si C dapat ay intermediate between A and B. Okay? Pero sa elementary calculus, baka ang ginamit niyo ng theorem, lalo na't kung alam niyo si F ay integrable everywhere or continuous everywhere, si C ay kahit anong number. Mapa nasa labas siya ng closed interval AB or wala. Okay? So, pwede siyang lumampas ng A, pwede siyang lumampas ng B. Pero in our case, restricted tayo na si C ay dapat nasa pagitan ni A and B. One reason is that, if you will recall, in our definition of the Riemann integral, yung lower bound, siya laging left endpoint ng isang interval. Yung upper bound ng integral, siya lagi yung right endpoint ng interval. So laging si A ay strictly mas maliit kaysa kay B. Kasi nga laging binabalik natin, this is the integral of F on the closed interval AB. So if A is greater than B, it doesn't make any sense, right? Because wala naman tayong closed interval na mas malaki yung left endpoint kaysa dun sa right endpoint. Okay? So kaya ngayon limitado tayo na laging yung lower bounds ay mas malaki sa upper bounds. And that's the reason why C is restricted to be a number on the open interval AB. Pero later, probably, siguro sa isang problem set problem redundant, or sa isang homework, ano, so pwede kong ipaprove na totoo ito sa kahit anong C, as long as F is known to be integrable on the largest possible interval that contains A, B, and C, or which will have two of them the endpoints. Okay? Pero ito yung medyo kaibahan, ano? Kasi wala tayong integral na mas malaking nasa lower bound kaysa sa upper bound. Okay. But anyway, we will resolve that later when the need arises. Pero prove muna natin ito. Now, the proof would be, we'll use a usual technique, all right, na ginagamit sa analysis proofs. Ito yung gusto nating ipakita, na pwede nating i-split up yung integral. Mag-integrate ka muna mula kay A to C, tapos mag-integrate ka from C to B, tapos i-add mo sila para makuha mo yung integral dun sa buong interval AB. Okay? Now, a usual trick in analysis, pag nagpo-prove ka ng identity o ng equality, pwede mong gawin na ipakita yung less than or equal to relation. Kung mahirap yung direktang ipakita na sila ay equal, pakita mo muna na less than or equal. Tapos, susunod mong part ng proof, pakita mo naman yung greater than or equal to relation. Kung sila ay parehas totoo, less than or equal to and greater than or equal to ay parehas totoo, there's only one way to reconcile these two things, and that is to conclude yung equality nung left at saka nung right-hand side. At yun yung gagawin ko rito sa ating proof for this statement. Dalawang sub-proofs yung susulat ko. Isa para sa less than or equal to, isa para sa greater than or equal to. All right? Now, how do we write the proof for this? Okay. Now, okay. So I will consider an arbitrary epsilon greater than 0. Okay. And then the purpose of this will be much clearer later. Pero let's first note na dahil si F, alam na natin by the assumption in this PS proof, ano, yung PS na to, integrable na si F sa closed interval AB. So, ibig sabihin yung Riemann integral ay equals sa upper Riemann integral. right? And the upper Riemann integral is the infimum. Yeah, it is the infimum. This is the greatest lower bound. So in the first place, the Riemann integral pala ay isang lower bound. Lower bound nino, lower bound ng mga upper sums, right? Kasi yung upper integral siya yung infimum ng mga upper sums. So the Riemann integral then will be less than or equal to any upper sum, or the upper sum of f relative to any partition inducer. Tapos by Theorem 5.1, alam natin na pag binigyan tayo ng epsilon greater than 0, may nag-exist na p such that this guy is less than epsilon. Alright? Tapos pag nag-add ako ng lower sum of f relative to p to both sides, makukuha ko ay u less than epsilon plus L. And that's what I got here. Alright? So good so far? So inuunti-unti natin yung mga inequality. Bakit lumabas yung inequality dyan? Tapos, yung natutunan natin kanina na property, kasi si lower sum lang naman ay summation ng mga lower sums relative to the partition inducer, pwede ko siyang hatiin sa dalawang parts. Ano? So pwede ko itong isulat as the lower sum relative to P1, where P1 is P intersection the closed interval AC, tapos plus the lower sum of f relative to P2, where P2 is P intersection C, comma B. So in-split ko lang siya into two parts, alright? Kasi summation lang yung lower sum. So parang sum, makukuha ko yung final answer, no? And then there would be a plus epsilon in here. Alright? Okay, then, anong masasabi ko? Oh, this guy, si f ay integrable sa closed interval AC by assumption. Ano? So, ibig sabihin, ito ay laging less than or equal sa supremum niya, alright? Which is basically the lower sum of f relative to AB. The lower sum of f from A papunta kay C. Right? Kasi ito nga ay supremum, least upper bound. So it's an upper bound in the first place. So this guy is smaller than the Riemann integral from A to C. In the same token, this lower sum is less than or equal to the Riemann integral of f from C to B. Kaya meron ka diyang less than, kinopya ko yung epsilon o yung plus epsilon sa dulo. So in summary, what we have seen here is that the Riemann integral is less than, strictly less than, this guy. Integral of f from A to C plus integral of f from C to B plus epsilon. And the thing here is, this is true for any epsilon greater than 0. So yung isang sinaunang lemma na galing pa sa unit 1, alright, will kick in. That is, if you have something that is less than another thing plus any positive number, then the first thing is less than or equal to the second thing. And that's what I have established here. Right? Tapos para mabuo yung proof, ipapakita ko naman na totoo yung greater than or equal to relation. Alright? Now, I will use a similar argument. So pero magsisimula naman ako dito. Dun sa sum ng dalawang sub-integrals. And then I will use the fact that the same argument, now this is equal to the upper Riemann integral, which is the infimum of all the upper sums. Being the infimum of the upper sums, it is a lower bound in the first place. So this guy is smaller than this. Tapos ito, mas maliit ito kesa naman dito sa kahit anong upper sum. Okay? Tapos gagamitin ko yung integrability criterion 5.1 doon sa P1. So yung U minus L relative to P1 ay mas maliit sa epsilon over 2. Yung U minus L relative to P2 ay mas maliit sa epsilon over 2. So basically this plus this guy will be less than L plus epsilon over 2. This guy will be less than L plus epsilon over 2. So their sum will be less than the sum of the lower sums relative to P1 and P2 plus epsilon, where epsilon is arbitrary. Okay? Tapos gagamitin ko lang yung property na ang sum nitong dalawa ay equal lamang dun sa lower Riemann sum relative to P. Tapos magiging less than plus epsilon. And then this guy is a lower sum. But this guy, knowing that f is integrable on the closed interval AB, this is also the lower Riemann integral. The lower Riemann integral is the supremum of the lower sums. So any lower sum must be less than or equal to the Riemann integral. Kaya ito ay naging less than or equal to, kinopya ko lang yung epsilon dito. And in summary, what we have shown is that the sum of these sub-integrals is less than the integral plus epsilon. And this is true for any epsilon greater than 0. So by the sinaunang theorem na natutunan natin simula sa unit number 1, okay, dapat ito ay less than or equal kay integral of f on the closed interval AB. And that inequality. So in summary, meron tayo nito, and we have the reverse inequality. So there's only one way to go. We need to conclude yung equality ng dalawang values. Okay? Siguro pag nagturo uli ako ng 155, parang hindi yata ako next semester. Pero papangalanan ko na yung lemma na yung less than epsilon, nawawala yung epsilon, nagiging less than. Papangalanan ko siya kasi ilang beses natin siyang ginamit sa units, I think, 3 and 4? 3, 4, and 5, ano? So, yeah, marami siyang gamit. So, papangalanan ko na nga siya. Actually, kahit sa unit 2, ginamit pa rin natin siya. All right. So, questions about the proof of theorem 5.7? Okay, so kung wala naman, so let's take a look at theorem 5.8. And these guys are some of the results that you had been using since elementary calculus. Ano? So kapag ka alam mo si f at saka si g ay integrable on the closed interval AB, then yung sum nila ay integrable din. At ang integral ng sum ay sum ng integrals. Now kapag ka si f ay integrable, tapos minultiplyan mo siya ng kahit anong constant, yung constant multiple na yon ay integrable pa rin, kasi yung integral ng constant multiple ay constant multiple ng integral. And then kapag ka si f ay bounded, say it's bounded below by little m, it's bounded above by capital M, then the integral of f is also bounded. And it is bounded below by little m times b minus a and big M times b minus a. Tapos, siguro pwede nyo itong tingnan as yung unang integral order theorem. Okay? Kasi sinasabi niya paano nagbe-behave yung succession ng integral with respect to the order relations. Ano? Also, mas general na integral order theorem, si part D, na kapag ka si f ay laging less than or equal kay g sa buong interval AB, then yung integral ni f lagi ring less than or equal sa integral ni g. So parang pag meron kang inequality na to, you can safely integrate both sides of the inequality without changing the sign of the without changing the inequality, right? But again, you can only do so if you're sure that f and g are both integrable. Kasi pag hindi integrable silang parehas, baka naman meron diyang isa na hindi mag-exist. Okay? Then let me see. Meron yata ang message. Okay, bilang GC naman. Kala ko sa klase natin. All right. And then the last one is kapag ka si f ay integrable, yung absolute value niya ay integrable din. And moreover, yung absolute value ng integral ay less than or equal sa integral ng function values. Okay? So, I will skip the proof. Ano? So, kasi yung proof naman ay binigay naman in details dito sa lecture notes. So, nandyan silang lahat. So, treat this as a reading assignment. Maganda siyang practice para makita nyo, para gawin nyo yung ginagawa natin sa klase, right? Gawin nyo siya on your own. Yung katulad nung kung paano ko siya dinidiscuss, ano? Kahit nandiyan na yung theorem, kailangan ko mag-insert ng ilang mga detalye or ipaliwanag bakit totoo itong inequality na to, bakit klaro daw na nagpa-follow itong result na to from a previous result. So I think this will be a good practice of reading proofs, ano? So, yeah. Pero palusot ko lang 'yon para matapos ko talaga yung 155 today, ano? So, but if you encounter any problems with reading the proofs, then just let me know. I'll be more than happy to walk you through these proofs, all right? But this is I felt this would be a good reading assignment because hindi na kayo mag-struggle na tanggapin itong mga statements na yan. Okay? Kasi ito yung mga statements na bata pa lang kayo sa calculus, ginagamit nyo na ano. So kaya maganda siyang pag-practicean ng proofreading. At least you're familiar with the results. Now, kukumbinsin nyo yung sarili nyo kung bakit siya totoo. And the proofs are very similar dun sa ginagawa na natin before. Gumagamit tayo ng Theorem 5.1, kinukuha ko yung supremum, infimum, hinahati ko sila sa mga subintervals, and so on. Okay? So, yeah, that would be your reading assignment. And then, tatalo na ako ngayon, papunta sa Theorem 5.9, second to the last theorem for the course, which is basically the mean value theorem for integrals. Okay? Oh, by the way, nakapag-decide na pala ako kaninang umaga kung ano yung last homework because I promised we'll have 8 homeworks. Nakapito na tayo. So may isa pang homework. Kaya lang nakalimutan ko. So silipin ko yung lecture notes kanina. Okay. Sa Fundamental Theorem pa pala. Okay. Kala ko sa Theorem 5.8. So hindi pa pala. So ibibigay ko na ngayon yung homework number 8 na last homework. Tapos ang deadline niya ay sa June 9. So pero ibibigay ko na siya ng maaga. Pero tama ba? Kailan yung deadline ng homework 7? Next week na, no? May 31 nga ba? I think May 31, kung hindi ako nagkakamali. Tapos, June 9 yung isa. Tapos, nabigay ko na yung problem set. Alright, so, tapos, baka pwede na tayong hindi mag-meet next week para dun sa 1.5 hours na supposedly gugugulin nyo pag-attend ng klase ko or panonood ng recording natin ay pwede nyo nang gawin yung mga problem sets, ano? Para makabawas-bawas dun sa, alam ko, hell week nyo na starting next week probably or during the last week of classes. But probably I can also extend the deadline, okay? Siguro hanggang 2 days before the final exam na isa-set ng registrar. So just keep your submissions going. Tinatanggap ko naman siya via email, ano, kung makakalampas na kay Canvas. Pero ang priority kong checkan ay yung mga nakasubmit on time kay Canvas. I think I finished grading homework number 6 kaninang madaling araw. So, try ko nang simulan yung checkan yung problem set 2. Siguro later today, kaya lang may meeting pa ako after ng klase natin. Pero siguro madaling araw mamaya. Hindi. Pagpupuyatan ko pala yung lecture sa 175 mamaya. Pasensya na, crammer ako eh. So, kailangan kong malapit na yung deadline bago gawin yung mga bagay-bagay. But yeah, I'll start grading it over the weekend. Probably I'll make some progress into it. So kindly watch out for that. Now, going back. Thank you, Jonathan. Next week nga yung homework 7. And then week after next yung homework 8. Kasabay nung problem set number 3. All right. Now, let's go to the mean value theorem for integrals. Now, itong mean value theorem na to ay ito yung general case ng mean value integral. Ikukwento ko na lang kung ano yung nangyari dun sa specific case ng MVT, which is, I think, the version of the MVT for integrals that you have seen in your elementary calculus classes. Ano? So, ang assumption natin dito sa MVT natin for integrals, meron tayong dalawang functions. Yung unang function f, alam natin na siya ay continuous sa closed interval AB. Now, continuity is a much powerful result than integrability kasi meron tayong theorem na kapag ka continuous ka, automatic ikaw ay integrable. Pero alam natin kapag ka ikaw ay integrable, hindi ibig sabihin continuous ka na kagad. So kaya mas malaki yung hinihingi natin dun sa function f. So hindi nyo pwedeng pagbaligtarin yung roles ni F at saka ni G sa MVT na ito. Kasi si F, mas malaki yung hinihingi natin mula sa kanya. Alright? So we're asking F to be continuous. Meanwhile, G needs only to be integrable on the closed interval AB, and it is non-negative all throughout the interval. Okay? Now, pwede ko itong i-relax, alright? Kaya lang maiiba yung proof kapag hindi ko inassume na si G ay always greater than or equal to 0. Okay? So, kaya mas padaliin na lang natin yung MVT natin. Assume natin si G ay greater than or equal kay 0. And then, ang sinasabi ng MVT, may nag-exist na number C dun sa closed interval AB such that the integral of the product is simply a scalar multiple of the integral of G. Okay, and the scaling factor is a function value of F, the function value of F at the number C. So may nag-exist na number C, which we call to be the this is called the average value of F, such that si F na continuous, pwede ko siyang ilabas ng integral, pero function value niya at a specific number C. Unfortunately, hindi sa atin binigay ng MVT kung ano yung number C. Eh di sana ang dali nang mag-integrate ng product. So kung binibigay ni MVT yung C, so pag nag-integrate ka ng product, hindi mo na kailangan mag-integration by parts. So pwede mo nang ilabas si F, evaluate siya sa C, tapos i-integrate mo na lang si G. Alright? Kaya lang hindi fair ang mundo, hindi madali ang mundo. So pagka komplikado si F at saka si G, IBP pa rin ito. Pero at least alam natin na kung magaling ka na maghula ng C, so yung integral ng product ay equal lamang dun sa product ng function value at that specific number C times the integral of G. And again, don't confuse or don't interchange the roles of F and G. Si F siya yung continuous function, siya yung lumalabas ng integral. Alright? Hindi si G, kasi si G pwedeng hindi siya continuous. Ang requirement lang kay G ay integrable at saka non-negative. Okay? Now, yung siguro nakita yung version ng mean value integral and probably how the mean value theorem got its name. So, specific case lang nito when G is equal to 1 all throughout the interval AB. Okay. Kasi kapag si G ay equal kay 1 sa buong interval AB, then the left-hand side will just be the integral of F on the closed interval AB, kasi si G nga ay 1. Tapos, ang right-hand side ay F of C times the integral of 1 on the interval AB. Pero alam natin, lumalabas yung constant sa integral, or actually ang integral ng 1 from B to A, from A to B, ay equal lamang kay B minus A. Tapos pwede kang mag-divide both sides ng B minus A. Okay? Makukuha natin to. So ito yung usual statement ng mean value theorem for integrals. Meron tayong mahanap na element ng closed interval AB, tawagin natin siyang C, na yung function value niya ay equal dun sa quotient ng integral over B minus A. Okay? This value here is what we call the mean value or the average value of the function f on the closed interval AB. Bakit siya average value? Kasi di ba pag nag-average tayo sa discrete set, halimbawa sa stat, kinukuha natin yung summation ng mga ina-average natin, tapos dinidivide natin by the number of addends. Ang problema rito ay, kapag kukunin natin yung average value sa isang closed interval, hindi siya discrete. So, hindi natin naiisa-isa yung sinasum natin. And actually, ang extension ng summation ay integral. So, yung summation ay para sa discrete at finite. Actually, hindi kailangan finite. Para sa discrete, yung continuous version niya sa isang interval, sa isang compact set, yan na yung integral. Okay? Kaya sabi ng iba, kaya pinili ni Leibniz na ito yung symbol ng integral. Kung bakit parang uod yung pinili niyang interval notation para sa integral. Kasi ito daw ay isang elongated na S, isang mahabang S. para sa salitang sum. So siya yung parang generalization ng summation. Okay? Kaya ganun yung symbol natin for the integral. Okay, and then we were supposed to divide it by the number of terms. Kaya lang, hindi natin kayang bilangin ilan yung mga elements ng closed interval AB. There would be infinitely many of them, pero hindi siya magandang measure ng closed interval AB. Speaking of measure, nasabi na natin before na ang measure ng interval ay yung haba ng interval. Kaya instead of dividing by n, i-divide ko siya by the measure of the interval, which is b minus a. Kaya indeed, ito yung tinatawag natin na mean value. So basically, the MVT or special case of the MVT tells us that there is an element of the closed interval at which f attains its mean value. Right? So ngayon, tingnan natin yung proof ng mean value theorem. Okay? Now, sisimulan natin dun sa assumption. Ito kung bakit mahalaga na si f ay continuous. Kasi kung si f ay continuous sa closed interval AB, then si f ay continuous sa isang compact set. So the Weierstrass theorem or yung extreme value theorem will kick in. Ibig sabihin, may mahanap tayo na x sub little m such that, x sub capital M such that f of x sub capital M is the maximum function value. And similarly, we can find an x little m such that the function x sub little m belonging to the closed interval AB such that the minimum value of f over the closed interval AB is equal to f of x sub little m, which we can call as little m. All right? So nakukuha niyo yung maximum at saka minimum doon sa loob ng closed interval AB. Kasi nga si f ay continuous. So ibig sabihin, si m ay less than or equal kay f of x, which is less than or equal to capital M for all x's in the closed interval AB. Tapos ang gagawin ko, mag-multiply ako ng all sides nito by g of x. And that is fine because g of x is always greater than or equal to 0. So when I multiply all sides by g, hindi nababago yung inequality. Alright? Tapos, alam ko to ay totoo sa lahat ng x's sa closed interval AB. So pwede kong gamitin yung isang statement dun sa theorem 5.8, yung second integral order theorem. Okay? So if you have a relation between quantities or between functions, you can simply integrate and preserve the inequality relation. Okay? Tapos si m, being a scalar multiplier, can come out. Tapos si capital M, scalar multiplier then can come out. So we will end up with this inequality. All right? Tapos ngayon, kailangan na nating hanapin sino si C na pipiliin ko na magbibigay sa akin ng function value na such that f of c times the integral of g ay magiging equal sa integral ng f times g. So yun yung goal, ano? So apparently, para mahanap si C, kailangan kong hatiin yung paghahanap kay C into two cases. Siguro at this point, sir, bakit pa hatiin? Makikita nyo later kung bakit siya kinailangang hatiin. Yung unang case, inassume muna na si G ay 0. Okay? Or yung integral ni G ay equal kay 0. Kung yung integral ni G ay 0, so ibig sabihin, ito ay 0, ito ay 0. So ibig sabihin si integral of f times g on the interval AB ay less than or equal kay 0, pero greater than or equal than kay 0. So no choice tayo but to conclude that the integral is also equal to 0. Yung integral ni fg ay equal kay 0. Tapos madali na yun. So kasi si integral ni fg ay equal kay 0. Okay? Tapos sabi natin, naghahanap tayo ng c such that f of c times integral of g from a to b ay magiging equal sa integral ng product. Integral ng product ay 0. Oh, but in this case, we assume that the integral of g ay equal kay 0. So that means f of c can be anything. All right. So that means I can choose c to be any number on the closed interval AB. Right? So you can say, sige, si c ko ay a plus b over 2. Where in reality, si c kahit anong number dun sa closed interval AB. Totoo pa rin si MVT provided that the integral of g is equal to 0. So siguro isipin nyo, kaya pala ito hinati sa dalawang cases. Kasi madali yung case ng integral ni g ay equal kay 0. Actually, you can think of it that way, pero I don't want to see it in that light. Ano? Necessity kasi na talagang hatiin ko sa dalawang cases. Bakit? Kasi yung case na kapag si integral ni g ay hindi equal kay 0, that will allow me to divide all sides of the inequality here by the integral of g. Okay? Hindi ko to kayang gawin kung hindi ako sure na hindi 0 si integral ni g. Pero we already taken care of the case when the integral of g is equal to 0, so it's perfectly fine. I can divide all sides by the integral of g. Okay. So doing so will give us this inequality. All right. But what is this? Little m is f of x sub little m, and then f is, or capital M is f of x sub capital M, right? Plus ano pa yung alam natin, si f ay continuous sa closed interval AB. Dahil si f ay continuous sa closed interval AB, then the intermediate value theorem will kick in. Anong sinasabi ni IVT? So kung continuous ang isang function sa isang closed interval, sa kahit anong number sa pagitan ng function value sa kaliwa at sa kanan, lagi kang may mahanap na element ng closed interval na ang function value ay equal din sa arbitrary number na napili natin kanina. All right? In this particular case, I know that f is continuous on the closed interval AB, so it will be continuous on the closed interval having x sub little m and x sub capital M as the endpoints. So ibig sabihin sa kahit anong number sa pagitan ni f of xm at saka ni f of x capital M, there exists a c, all right, between xm and x sub capital M. Hindi ko kasi alam kung sino yung mas malaki sa kanila, kaya hindi ko masulat as a closed interval. Pero alam ko, laging may mag-exist na c sa pagitan nila. Pero alam natin si x sub little m at saka si x capital M nasa closed interval AB. So ibig sabihin yung c na nasa pagitan nilang dalawa ay nasa closed interval AB rin. So there exists a c between A and B such that yung function value ni c ay equal dito. So ito yung k dun sa IVT na gagamitin ko. Alright? So there exists a c such that f of c is equal to this guy. Multiply both sides by the integral of g, we will end up with the desired identity. All right? And that ends the proof of the mean value theorem. Okay? Okay, ratsyada na natin to. So unless you have questions, nakita ko nag-heart na si Jonathan, so I guess he has no questions. About you, Anna and Oriel. Medyo pinapaspasan ko eh. So I hope everything is still clear. Right. Now, pupunta na tayo dun sa graduation ng 155, which is basically the Fundamental Theorem of Calculus. Now, but before going there, kailangan ko muna mag-insert ng isang definition. Ano yung nangyayari kapag or paano natin i-define yung integral kapag yung lower bound ay mas malaki na sa upper bound? Okay? Which doesn't make sense from our definition before kasi laging nakadepende siya sa closed interval AB. So by construction, yung Riemann integral ay laging merong lower bound na maliit at upper bound na malaki. Now, to allow us to investigate things further, all right? So pwede ko ngayong i-define kung ano yung mangyayari kapag mas maliit yung upper bound kesa sa lower bound. Okay? Now, I will set that the integral of f from a to b is equal to the negative of the integral of f from b to a. Okay? Nagkaroon lang dyan ng minus sign. So probably in elementary calculus, ginamit natin to as a theorem, all right? Or in-state natin as a result or as a formula. Pero sa 155, isa siyang definition. Kasi dinefine natin mula sa pole ng integral lagi, mas malaki yung upper limit kaysa sa lower limit. Pero so hindi mako-cover ng definition natin ito. So isa lamang ang makakapagtama ng isang definition. Isa pang definition, all right? So that's why we don't need to prove it. We just need to accept it as a fact because it is a definition. Walang ko-kontra, convention ko ito. And this convention will prove to be consistent with our theory. Kasi pagka merong isang theorem na hindi na totoo, kapag ka inaccept natin tong definition na to, then this definition will not have any place in our axiomatic system. But apparently, this is fine for our Math 155 development. Moreover, if you're integrating over a singleton, okay, so ang interval natin, isa lamang yung laman, meron ka lang interval C to C, i-define natin yung integral ni f from C to C to be exactly equal to 0. And again, this is a definition, no need to prove it. And then this proves to be consistent with our entire theory, so okay tong gamitin as a convention. Okay? Tapos ito na, yung exciting part, the Fundamental Theorem of Calculus. Now, may dalawang statements itong Fundamental Theorem of Calculus. Statement A is basically the tying of the knot between derivatives and integrals. Okay? So, kasi sinasabi nito kung si f ay continuous sa closed interval AB, tapos si function capital F ay equal dito, the integral from a to x of f of t dt. Then sabi nito si f ay continuously differentiable, and not just that, the derivative of f is equal to little f. Right? So, ang nangyari lang, parang dinifferentiate ko lang both sides dito with respect to x, alright? Tapos ang nangyari, ang kiniklaim ng FTC, yung f prime ay equal daw kay f of x. So, ibig sabihin, itong ddxf, ito lang ay f prime. Tapos dito pala, yung derivative, ika-cancel niya lang yung integral, so matitira lang ay si f evaluated at the upper limit, which is the variable x. So kaya sinasabi natin, ito yung parang ito yung convergence point, kung saan nagtagpo yung derivatives at saka integrals, na nakita natin na si differentiation ay inverse process ni integration and vice versa. Okay. And that's one of the reasons why I think this is called the fundamental theorem, because it wove together these two giant ideas in calculus. Kasi otherwise, pwede mong tingnan as magkaibang subject yung differential calculus at saka yung integral calculus. But thanks to the fundamental theorem, they are indeed one and the same subject, or one and the same theory. Okay. And then yung second statement is siguro ito yung tinawag namang FTC because of its practicality and its ubiquity. Pag nag-evaluate tayo ng definite integral, hindi na tayo pumupunta dun sa pagkuha ng limit ng Riemann sum or pagkuha ng supremum ng mga supremum ng mga lower Riemann sums or infimum ng mga supremum ng mga lower Riemann sums o infimum ng mga upper Riemann sums. Okay? So kailangan humahanap lang tayo ng antiderivative. Humahanap tayo ng isang function na pag dinifferentiate natin, ang sagot ay si integrand. Tapos ang sinasabi ng FTC part B, yung integral ni f from a to b is the function value of b under the antiderivative f minus the image of a under the antiderivative capital F. So ito naman for practical reasons, ito ay for theoretical reasons. So try nating i-prove itong fundamental theorem. So, okay lang yun guys kasi last na natin tong ipo-prove sa lecture, ano? So, una, prove natin ito. Oh, by the way, when we say continuously differentiable, ibig sabihin si f at saka si f prime ay parehas continuous sa closed interval AB. Right? So, yun yung ibig sabihin ng continuously differentiable. But I will just prove etong statement na to, na ang derivative ni capital F ay si little f. And then I will leave as homework number 8 yung pagpapakita na si big F at saka si big F prime ay parehas continuous. Okay? Alright. Now, paano ko yung makapapakita na yung derivative talaga ni capital F ay si little f? Well, gagamitin ko yung definition ng derivative. Si f prime ay equal sa limit ng difference quotient. Okay? Pero ano nga ba si capital F of x plus h? Note that capital F is defined this way. All right? So that means capital F is the integral from a to x plus h of little f. Minus, ito namang capital F, integral lang siya from a to x ng little f. Ano? Kaya lang, mahirap mag-evaluate ng limit at this particular point. So, itatry ko itong i-simplify. Ano? So, paano ko ito masisimplify? Gagamitin ko yung dahilan or ito yung dahilan kung bakit in-insert ko yung definition 5.8 na pag nagbabaligtad tayo ng bounds of integration. Ano? Kasi ang gagawin ko, pagbabaligtarin ko yung bounds, oops. Tapos alam na natin ang bayad pag nagpapalit tayo ng bounds. Nagkakaroon ka ng negative sign sa unahan. Pero meron ka negative at saka negative, magiging positive na yon. Alright? Tapos, magagamit ko yung theorem 5.8.a, yung una dun sa mga integral theorems natin na, okay, parang hinati ko lang yung interval doon sa subdivision point A. Alright? So, ibig sabihin, ito ay integral from x to a. Ito ay integral from a to x plus h. Yung sum nila, actually, ay magiging integral lang from x to x plus h of f. Right? By theorem 5.8 or one of the statements therein. Okay? So, essentially, ito palang f prime ay limit lamang nitong guy na to. Right? Tapos, ang gagawin ko ngayon, gagamitin ko si Mean Value Theorem. Kasi si little f was assumed to be continuous on the closed interval AB, so the Mean Value Theorem will hold. Okay? Anong sinasabi ng Mean Value Theorem? Right? So, ito ay pwede kong tingnan as f times 1. So, si g ay equal kay 1. So, ito yung specific case ng Mean Value Theorem. Okay? So, that means there exists a c between x and x plus h such that, okay, ang f of c times the integral of 1 from x to x plus h ay equal sa integral ng f from x to x plus h. Right? Pero alam natin yung integral ng 1 ay haba lamang ng interval. Ang interval natin ay x to x plus h. So, ang haba nun ay h. So, equal siya kay h. So, ibig sabihin, itong kinukunan natin ng limit, pwede ko siyang isulat na f of c times h. And that's how I got this guy for our limit, right? So, si f prime ay equal dito. Oy, may h dito. May h pa doon. So, pwede ko silang cancelin. Kasi sa limit, pwede ka mag-cancel sa loob bago ka mag-evaluate ng limit, right? So basically, we're left with the limit of f of c. But take note that c is not independent of h. Ang alam natin si c ay isang number sa pagitan ni x at saka ni x plus h. But I don't know what c exactly is, but I know that it is dependent on h. So anong mangyayari kapag ka si h palapit na ng palapit kay 0? Kapag ka si h palapit na ng palapit kay 0, ibig sabihin, itong right endpoint, palapit din ng palapit kay x. So essentially, as h vanishes down to 0, isa na lamang yung nagiging option natin para maging value ni c. si C ay nagiging equal na lamang kay X. Kasi umuunti na ng umuunti yung choices natin. Alright? So therefore, as H approaches 0, f of C will be equal to f of X. And so that means si f prime of X ay equal kay little f of X. And that's what is claimed in the fundamental theorem. Okay? And then yung natitirang statement, sa statement, natitirang proof dapat ng statement A will be your homework. Homework number 8 will be for you to show that f is continuously differentiable. Okay? So you need to show for homework 8, i-announce ko dito sa Canvas later, no, na si capital F at saka si capital F prime ay parehas continuous sa closed interval AB. Para talagang matapos ko na yung course ngayong linggo. Okay? So, any questions with the with the proof of the first part of the fundamental theorem? Or malamang pinag-iisipan nyo na yung homework 8, ano? So, tingnan natin yung huling part. Yung huling part ay ipakita na totoo itong statement na to. Alright? The Riemann integral of f from a to b is just the difference of the function value of b at an antiderivative minus the function value of a under the same antiderivative. Okay? So, yun yung ipoprove natin kayo. Now, paano ko siya gagawin? Well, kukuha lamang ako ng arbitrary regular partition. Or actually, I will consider the sequence of regular partitions, P sub n. So si P sub n, simula kay x sub 0 hanggang kay x sub n, pero yung layo sa pagitan ng dalawang consecutive partition points ay b minus a over n. So if n is equal to 1, so start lang tayo sa x0 hanggang kay xn. Kapag si n ay 2, so ang distance between them would be the midpoint. So si x, si a, tapos si a plus b over 2, tapos si xn, and so on. Pagpalaki ng palaki si n, parami ng parami yung elements ng partition inducers, paliit ng paliit yung common difference. Okay? Now, if we are on the regular partition, pwede kong gamitin yung mean value theorem for derivatives sa bawat isang subinterval. Okay? So, dun sa interval x0 hanggang x1, sure ako continuous dyan si f. Kasi continuous si f sa buong closed interval AB. So, continuous din siya sa closed interval x0 to x1. Tapos sabi ng mean value theorem for derivatives, may mahanap tayo na number C1 sa pagitan ni x0 at ni x1 such that this difference will be equal to this guy. Alright? Mean value theorem for derivatives. Tas gagawin ko to sa lahat ng subintervals, x1 to x2, x2 to x3, hanggang makarating ako sa x sub n minus 1 hanggang x sub n. Alright? Parang baliktad yung sinabi ko. From x0 to x1, from x1 to x2, from x2 to x3, from x sub n minus 1 until x sub n. Gagamitin ko yung MVT. Tapos, remember, anong goal natin? Mapakita yung formula involving this one. Okay, yan yung gusto nating i-derive. Paano ko siya makukuha? Well, I can simply add up the left-hand sides of the equations. Okay? Pagka in-add ko itong lahat, x1, may x1 dito. Si x2, makakancel yan ng x2 rito. Si x3, makakancel siya nung nandito. Itong x sub n minus 1, makakancel siya nung nandito. Ito, na-cancel na yun ng ibabaw. So, matitira lamang ay si f of xn, which is f of b, tapos f of x0, which is f of a. So, yun yung makukuha ko after summing up the right-hand side. Okay? Tapos, isasum ko rin itong mga nasa, yun yung sum ng left. Ngayon, isasum ko yung mga right-hand sides. Okay? But before I do the summation, I'll take note first that this is delta x sub 1. This is delta x sub 2. This is delta x sub n. And all of them are equal to b minus a. So, pwede ko itong tawagin na delta x na lamang. Kasi pare-parehas lang naman sila. Tapos itong f prime of C1, alam ko kasi by assumption si f prime ay equal kay f. So I can treat this as f of C1. This is f of C2, and this is f of Cn. Kaya makukuha ko itong mga statements na yan. Tapos ito ngayon yung mga isasum ko. So magiging summation siya lamang ng mga f of Ci times delta x sub I. And this form should be familiar to you because this is basically a Riemann sum. Okay? So for now, what we have shown is that this difference is equal to a Riemann sum. And then what I'll do next, I'll take the limit of all sides, okay, or actually of both sides. Take the limit of this as n approaches infinity, but these two guys are independent of n, so yung limit nito ay equals to f of b minus f of a. All right? And then take the limit of the Riemann sum, okay? But assuming that f is integrable, the limit of the Riemann sum is exactly equal to the Riemann integral. So kaya yung Riemann integral ay equal kay f of b minus f of a, right? And that ends the proof, and that end of proof also ends the course. All right? So yon, tapos na tayo sa 155. So natitira na lamang ay yung mga utang nyo. So problem set 3, homework 7, homework 8, final project. Tapos utang ko pang checkan yung problem set number 2. Right? So any questions or concerns? Okay, mukhang wala na naman. So I will not schedule any synchronous session starting next week. But if you have some questions about the homework or the remaining requirements for the course, or kung meron lang kayong gustong i-consulta, just let me know para buksan ko yung meeting. I will be available from 2:30 to 4 still hanggang June 9. So naka-devote pa rin yon sa ang oras ko para sa inyo. So just let me know lamang kung gusto niyo makipag-meet. I can open up the meeting, but I will not schedule a formal meeting anymore. But watch out for my email announcements, especially for the final project or the final exam, submission or adjustments for the problem sets, and so on. So kindly watch out for those. Ano pa nga ba? Yeah. So chat na lang or email na lang tayo, no? So it was my pleasure handling this course. Actually, I guess the classes I had starting from last semester until now has been a very good welcome for me back sa UPLB. I really had fun for all of the classes that I'm handling, especially for this one, 155 section X. So I enjoyed it. So hopefully you did so too, and you got a couple of things at least na natutunan sa course na to. So yeah, even the good things will need to end. So with that, let's end the course. And for the last time, thank you guys for joining me, and let's see each other around. Okay? Bye, guys.